हेलो स्टूडेंट्स, हाउ आर यू? कैसे हो आप लोग? सो व्हाट वी हैव टू डू टुडे इज, लेट मी जस्ट चेक आउट. Escape velocity. Am I audible? Yes. So okay. So what we will do today is we'll try to understand the concept of escape velocity. Escape velocity is not much very much tough topic, but yeah, we can categorize it as one of most important topic of ours. As you can see, basically what we can do is, listen. Okay, so we'll try to do some questions based on the this topic, which is our escape velocity. And I have already explained it to you that what is escape velocity. Escape velocity is nothing but just the minimum velocity to require, sorry, minimum velocity required to escape the gravitational field of any planet or earth. Got it? Escape velocity is just the minimum velocity required to escape the gravitational field of any planet or earth. Got it? So this was all about the escape velocity, VE. Then after that we have learned the formula to calculate escape velocity of any planet, and we could use 2 gm by r. Now we just know gravitational constant, universal gravitational constant 6.67 into 10 ki power. You know the value of it. And m is mass basically, and r will be the radius. Okay. So these are the key points that are required to calculate the gravitational escape velocity of any object. Of any object, no, sorry, object of any planet. Yeah. And we have learned one more formula of escape velocity, which was under 2gr. And with the help of this one, we have already calculated the escape velocity of Earth. How? And it comes as 11.2 kmp's. Kmp's means kilometers per second. Yeah, it's pretty amazing fact, but you should and you need to learn this formula. So let us try to solve some questions. Suppose I am given with a question. Suppose we are here given with a question. The question states that calculate calculate the escape velocity. Calculate the escape velocity for an atmospheric particle. Atmospheric particle 1600 kilometers above 1600 kilometers above the earth's surface, given that the of the earth radius of the earth is 6400 kilometers, and acceleration due to gravity on surface of earth is 9.8 meter per second. So this is the question that we are given with. Great. So now we'll try to solve this question. It is not a tough question, but we can see that it is one of the important question uh, that can be appeared in your respective examinations or competitive examinations. Basically, what we need to calculate in this question, we need to calculate the escape velocity for an atmospheric particle which is at the height of 1600 kilometers above the Earth's surface. Basically, let us try to draw the diagram of it. Basically, a particle which is at the height 1600 kilometers, है ना? A particle P which is at the 1600 kilometers above the Earth's surface, given that the radius of Earth, you all know the radius of Earth, and its value is equivalent to 6400 of kilometers, and acceleration due to gravity here we are given with 9.8 meter per second square. Got it? Okay. So as we know, so what we can do is, we know the formula of escape velocity root 2 gh. Yeah, root 2 gr, I guess. Yeah, it is root 2 gr. I have written the wrong term. So we can specify 2g, and instead of capital R, we can write capital R plus h. Basically, capital R will be describing the radius of Earth, and h will be defining the height of the particle with respect to the surface of Earth. Okay, so escape velocity will be equals to under root of, great. But you know, at the height, at some height h, the acceleration due to gravity changes. है ना? So we need to use or put the formula of gh, which is the previous value, gr square upon r plus h whole square. You all know about it, and here we come r plus h. Got it? Then after that we can cut one values, r plus h whole square can be cut by r plus h single term, individual term, and we'll get root 2 g r square upon r plus h. Great. Okay. So as you all know, r plus h will be equals to 6400 kilometers. Everybody, we can write as 6400 kilometers plus h is 1600 kilometers. So their value will be 8000 kilometers into 10 ki power 3 meter. So what I have done is, I have converted the distance r plus h into the meters. Okay. So in the last step, we'll calculate the escape velocity. Either you can calculate in kilometers per hour, or you can go for kilometers per second, as you all wish. So r plus h, I'll write 8 into 10 ki power 6 instead of 8000 kilometers. So it will be in meters. 2. Value of g is 9.8, basically surface of Earth. And r is 6.4 into 10 ki power 6. So what I have done is, I have also converted r in meters. So what you can do is, you can take r in kilometer as well as r plus h in kilometer as per your basic need or requirements. Okay, beta. You know, either you can go for this method or you can go for mine. Great. Whatever you want to do. Great. So note down this question. I have done with my best. Try to note it down because I'm also having my plus class at 5 p.m. So I'll try to finish the class in 5 to 10 minutes. Hmm. Okay, so you have written this page. Okay, let's start this session. Okay, okay. So you all have written this question. Let me give you some questions for the homework. Great. Yeah. So just let us take this color. So I'm giving you some sort of question that you can do or try at homes. The radius, the radius of a planet, the radius of a planet is double that of Earth. But their average, but their average densities are the same. If the escape velocities. If the escape velocities at the planet and at the Earth are Vp and Ve respectively, then prove that Vp is equals to 2 of Ve. Try to do this question, then after that I'll. Okay, so you have to do this question as your homework. Try to do it, and bye bye. Take care. Meet you in the next class. Bye bye.